let's move on to a new chapter, which is exponents, powers, and surds. So first of all, let's talk about what are exponents, what are powers, and what are surds. So when we were talking about squares of number and cubes of number, we know that the square of a number is denoted by x square, right? And cube of a number is denoted by x cube, right? So x square and x cube denotes, two numbers with a base x and it's raised to 2 and 3, right? Now, these 2 and 3 are called powers, and this x square and x cube is called exponents, right? Now, 2 and 3 are exponents with the base x, right? And when we are talking about square root of x or cube root of x, now the thing square root and cube roots are called the surds. Now, let's dive deep into this chapter because we use exponents, powers, and surds in a lot of places, right? In mathematics, we solve different kinds of equation, which includes linear equation, quadratic equation, and everything. So, a linear equation wouldn't have any. If we write a number x, right? It means that x raised to 1. 1 is the power of that number, right? Now, if we are talking about x square, we have 2 as the power of the number, right? So let's dive deep into this and let's look at it. So first of all, what is exponential form? Exponential form, also known as exponential notation or scientific notation, is a way to represent numbers that involve very large or very small values using a base and an exponent, right? So here 2 square is the exponential form, that is we have a base number and we have a power, right? Now we have in 2 cube, 2 is the base and 3 is the power. And these are the 3 forms of expressing a number, which is exponential form, factor form, and standard form. So in a standardized way, if we have a number saying 86,400, right? How do we express this in an exponential standardized form? What do we do is, we'll have a number which is less than 10 but greater than 1 to be a number which is before the decimal place. Now we put a decimal point and we write the rest of the numbers, which is 6400 and 64 is same. Now, how much decimal points did we move? We moved 1, 2, 3, 4 decimal points, right? So we put 4 as the power of 10. What does this mean? This means that 8.64 is multiplied into what is 10 raised to 4? 1 and 4 zeros, right? We have 1 and 4 zeros. So when we multiply this by this, we'll get 8. We'll move 2, right? For 2 zeros, we are moving 2 digits. Now we have 2 zeros left. We'll add these 2 zeros and we'll get 86,400, right? Now this is called the exponential form of a number. Now let's talk about rational exponents. So what are rational exponents? Rational exponents are a way to express powers that are not whole numbers. Instead of using only whole number as exponents, we can use fractions and decimals as well. Rational exponents allows us to calculate the roots of numbers that are not perfect squares or cubes, making it easier to work with a wider range of numbers. So whenever we are talking about the powers of a number, we know that a square or 2 raised to 2 is equal to 4, right? Now, how do we write 2 raised to 1 by 2 as? How do we write 2 raised to 1 by 2? It's nothing. It's basically square root of 2 or simply the root of 2, right? In the same way, if we have a number raised to 1 by n, how do we write it? We write it as the nth cube of a. For example, if we have 8 raised to 1 by 3, it simply means that it's the cube root of 8, which is equal to 2, right? So this explains the first thing, which is a raised to 1 by n is equal to nth root of a. Now what is a raised to m by n? Now we know that a raised to 2 is a square, which is equal to 4 in the case if a is equal to 2, right? Now we also said that, let's say we have 8 raised to 2 by 3 as a number. Now this could be written as 8 raised to 2 into 8 raised to 1 by 3. How? Because that is a law of exponents. if we have an exponent a raised to mn, how do we write it? We could write it as a raised to m into a raised to n. That is a raised to m plus n. Now this is a raised to m plus n, right? Now let's split it. This is its plus. So basically what we're going to do is we take 8 square and cube 1 by 3 means the cube root of 8. So cube root of 8 raised to 2 is the numerator. We'll put it as the square. So we have 2 square which is equal to 4, right? We have 8 cube is 2 and 2 square is 4. Now that is the rule for writing this. That is, if we have a value a raised to m by n, it's the nth root of a whole raised to m. Or it can also be written as nth root of a raised to m. Now here, what is 8 square? 8 square is equal to 64. So we need to find the cube root of 64, which is equal to 4. Right? Now these are the properties of rational exponents. How do this help us? This helps us to write a wide variety of numbers. Just other than the whole numbers, we could write any numbers in this way. Now, let's move on to negative integral exponents. So what are negative integral exponents? Negative exponents are a way to express fractions or decimals as powers, right? When an exponent is negative, it means that we need to take the reciprocal or flip the number. So let's say if we have 2 raised to minus 2 as a number, what does this mean? This means that it's just 1 by 2 raised to 2. So negative means that we need to take the reciprocal of the number, right? This is equal to 1 by 4. Now, if we have a number 4 raised to minus 3, what does it mean? It just means that it's 1 by 4 raised to 3. Now, this is the condition of negative integral exponents, right? Now, laws of exponents. Now, this is a very important portion which would be used for the higher applications. Now, first let's talk about the zero exponent law, right? So, zero exponent law is a raised to 0 is actually 1. How did this happen? Let's say any number 2 raised to 0, that is 2 multiplied 0 times, that is 1, right? So, any number with a power of 0 is equal to 1. Now, identity exponent law. What is identity exponent law? It says that any number a when raised to a power 1 is equal to that number itself, right? So, if we have a raised to 1, that means that a raised to 1 is equal to a. Now, if we have 3 raised to 1, it's 3. 4 raised to 1 is equal to 4. Now, that's what we say about identity exponent law. Now, we have the product law, which we just talked about a little bit before, that a raised to m is multiplied the same base a, which is raised to another number n. We got a raised to m plus n. For example, we have 2 raised to 2 into 2 raised to 8. How do we find this? We'll keep the 2 here and we'll add the powers, which is equal to 2 raised to 10. Now we have to find what is 2 raised to 10, right? So we have 2 square is 4, 2 cube is 4 into 2, 8, 2 raised to 4 is 8 into 2, 16, 2 raised to 5 is 16 into 2, which is 32, 2 raised to 6 is 32 into 2, which is 64, 2 raised to 7 is 64 into 2, so we have 8 and 128. Now 2 raised to 8 is 8 2s are 16, 1 balance, 2 2s are 4 and 5. We have 2 here, 256. Now 2 raised to 9 is equal to this into 2, that is 6 2s are 12, 1 balance, 5 2s are 10 plus 1 is 11, 1 balance again. Now 2 2s are 4 plus 1 is 5, which is 512. Now what is 2 raised to 10? For 2 raised to 10, we have 2 into 2 is 4, 2 into 1 is 2 and 5 into 2 is 10. 2 raised to 10 is 1024. Now what is 2 raised to 2? It's 4 into what is 2 raised to 8? It's 256 is equal to 2 raised to, what do you say, 1024. That is 2 raised to 10. Now what is 256 into 4? We have 6 4s are 24, 5 4s are 20 and 22. We have 4 4 2s are 8 and 8 plus 2 is 10. Again we got 1024. Right? So this explains the rule that a raised to m into a raised to n, that is the same base raised to different powers, is equal to the base raised to the sum of the two powers. Now we have quotient law. In product law, we have a raised to m into a raised to n is equal to a raised to m plus n, and we have a raised to m in the quotient law, we have a raised to m divided by a raised to n is equal to a raised to m minus n. Now let's take the same example here. Let's take a raised to m as 2 raised to 8 divided by 2 raised to 2, right? This would be equal to, according to this law, 2 raised to 8 minus 2, right? So what is 2 raised to 8 minus 2 raised to 2? We have 2 into 2 into 2 into 2, this is 4 times, into 2 into 2 into 2 into 2, this is 8 times. Now this divided by 2 into 2, we'll cancel these 2's out and these 2's out. Now we have 2 multiplied by itself for 3 plus 3 6 times, this gives us 2 raised to 6. And what is 2 raised to 8 minus 2? This is also 2 raised to 6. Now this proves the quotient law. Now we have negative exponents that we already discussed about, that is, if a number is raised to a negative number, that means we take a reciprocal of that number, right? Now we have the power of a power. That is, if we have a number a raised to m and we say that this whole raised to n, what do? We just multiply the power with each other. That is a raised to m into n. That is, I am saying that 2 square whole raised to 2. Right? What does it mean? This means that 2 raised to 2 into 2 is 4. Let's see whether it's true. We have 2 square 4 and 4 square is equal to 16. Now what is 2 raised to 4? 2 raised to 4 is also 16. Right? This is the property which says the power of a power, that is a raised to m whole raised to n is equal to a raised to mn. Now we have the power of a product. So if we have a number a b whole raised to m, we could say that it is equal to a raised to m into b raised to n, right? That is, if we have 4, let's say we have a number, let's say 81 whole raised to, or let's say 24, right? 24 whole raised to 2. What do? We could write this as 2 raised to 2 into 12 raised to 2. How come? 12 into 2 is 24, and both of these squares we know this is 4 and this is 144, and this becomes easier. Or otherwise we could write the same number as, we know what are the factors of 24? We could do 6 into 4, 6 4s are 24, right? 3 into 8, 8 3s are 24. So we could write 6 4s is better. 6 square plus 4, 6 square into 4 square, which gives us 36 into 16, right? All of this is the same answer, right? Now let's talk about the power of a quotient, which is a by m whole raised to m. A by b whole raised to m is equal to a raised to m divided by b raised to m. Now these are the solutions, and these are a few laws of exponents. We have to solve a lot of problems from this area, because once this is clear, you could move on to any of the math problems which includes exponents, and it would be very easy to simplify all those things. Now we have laws of the exponents just written like this, right? Now, surds or radicals. So what is a surd or what is a radical? A surd or a radical is a special symbol called a square root. It looks like a little check mark or a hook. This thing is called the surd or a radical. It represents a mathematical operation that helps us find the missing piece or the number that when multiplied by itself gives us a certain value. A surd or a radical is a symbol that helps us find the square root of a number, right? Now it tells us the number that when multiplied by itself gives us the original number, right? So a multiplied by itself for n number of times would give us root of a, right? Would give us what? A, right? So nth root of a multiplied n times would give us a. So a surd or a radical is a symbol that helps us find the square root of a number. It tells us the number that when multiplied by itself gives the original number. Sometimes the square root is a whole number and sometimes it's a special number that we represent by using a surd or a radical symbol. That is, if we are taking root of 4, we know that it is equal to 2. But what is root of 2? What is root of 2? We don't know, right? It is actually root of 2 is a value which is equal to 1.41 something, right? But it's not a whole number. It gives us a special number and we denote this number as root 2, right? Now, surd in simplest form. When a surd is in its simplest form, it means that we cannot find any more perfect squares that can be taken out under the square root symbol. That is, if I am saying that I have a number 84 and I need to find the root of 84, is it the surd in the simplest form? No. Why? Because 84, when I'm factorizing it, how can I write it? We could write 2 here, so 4 2s are 8 and 2 2s are 4. Again by 2, I'll get 21, right? Now, I'm doing it by 3, I'll get 7 and 7, I'll get 1. So, we got 2 out of it. So, 2 into root of 7 3s are 21. Now, this is the simplest surd in simplest form. That means, in surd in simplest form, the number inside the root should always be the simplest, right? We cannot factorize 24 further again into a perfect square. Now, this defines that. Now, we have different types of radicals or surds. The first thing is a simple surd. A surd having only one term is called as a simple surd. That is, if we have a surd for 24, it's a simple surd. But what if we have root of 24 plus 36 or root of 24 plus root of 36? It is not a simple surd, it's a complex surd, right? Now we have pure surds. In other words, a surd which has unity only as a rational factor and the other factor being irrational is called pure surd. So, pure surds are surds like, let's say root 2, right? It just have 1 as a factor. Root 2, root 3, etc. are called pure surds, right? Now we have similar surds. 2 or more surds are said to be similar or like surds if they have the same surd factor. And also 2 or more surds are said to be similar or like surds if they can be so reduced as to have the same surd factor. Here we reduced root of 84 to 2 root 21, right? Now let's say that I have root of 21 and I have 2 root 21. Now the surds in these are both equal. Now these kind of surds are called similar surds. Now we have mixed surds. Surds which are not completely irrational as that can be expressed as a product of a rational number and an irrational number are called mixed surds. That is, if we have a surd like this, right? If I have, let's say we have root 8, okay? So root 8 can be written as root 2 into root 4. Which gives us, what is root 4? It's 2 and root 2 is actually an irrational or a pure surd. So a surd which have a mixture of irrational and a product of a rational and an irrational number is called a mixed surd. Now we have compound surds. So what are compound surds? An expression which contains addition or subtraction of 2 or more surds is called a compound surd. As if we have a surd like root of 48 plus 32. Now we have an addition sign in between, right? Now these types of surd, addition or subtraction sign in the middle is called the compound surd. Now we have binomial surd. Now if a surd have two surds, right? That is, here we have two surds here, that is root 48 plus root 32. These are not equal, but this is another one I'm saying. Root 48 plus root 32 is a binomial surd because it contains two surds, right? Now we have trinomial surd. If the same thing contains three surds, it's called trinomial surd. Now we have conjugate surds. So conjugate surd, if we have this, we'll take the same example. We had root 32 plus root 48. The conjugate surd of this would be root 32 minus root 48. Now these are called the conjugate surds, that is the same surd with the opposite sign in the middle, right? Now we have different methods of comparing two surds. The first one is the equiradical surds. So the surds of same order is called the equiradical surds. If I have square root of 21 and square root of 32, these both are equiradical. Now if I have square root of 21, square root of 32 and cube root of 21, they are non-equiradical. That is, these two have different orders of the surds, right? Now, any value inside the surd is called the radicand, right? What is a radicand? Radicand is something which we denote inside the surd, right? Now, how do we compare equiradical surds? To compare equiradical surds, you can simplify them into the simplest form and then compare their numerical values. The simplest form of surd is when the radicand does not have any perfect square factors. Okay, so how do we compare two equiradical surds? We have root of 21, just like we said here, and root of 32. We have to compare these. One option is to find the root of these numbers. So what is it? Let's find the simplest form. We could do it by 3 and 7 is 7 and 1. So this is root 21 only. We can't simplify it further. Now what is root 32? 32 by 2 we'll have 1 2s are 2 and 6 2s are 12. Again by 2 we have 8. Again by 2 we have 4. Again by 2 we have 2. Again by 2 we have 1. So we have 2 into 2, which is 4 root 2, which is 4 root 2, right? Now 4 times root 2. Where is root 2 lying? Root 2 lies in between. You know, root 2 would lie in between. We know root 4 is 2. Root 3 we don't know, root 1 is 1. So root of 1 is 1 and root of 4 is equal to 2. So root 2 lies in between 1 and 2, right? Now where does root 21 lie? We know that root of 25 is equal to 5 and root of 16 is equal to 4, right? It lies in between 4 and 5. This would lie in between 4 and 4 into 1 and 2. So 4 into 1 is 4 and 4 into 2 is 8. And this would lie in between 4 and 5, right? So this is actually a very complicated guess to make because 4 and 5 and 4 and 8, it's basically the same interval. So there is another way to do it. In these situations, what do? We actually compare these two radicands. We compare the radicands. If they are equiradical, we compare the radicands. We have 21 and 32. So which is bigger? 32 is bigger. So root 32 would obviously be greater than root of 21. Now this is a very simple way to do it. If we can't find the numerical value, or if we have been in this situation where we could only say that it's between 4 and 5 and 4 and 8, it's basically the same range, right? We don't know whether it's greater or lower. What do? We take the radicands of both these numbers and compare them with each other, and the greatest number would always have the greatest root, would have the greatest number. Now we have comparison of non-equiradical surds. To compare two or more non-equiradical surds, first we have to convert them into equiradical surds. Then we have to compare the radicands of the equiradical surds. Using the least common multiple of the orders of non-equiradical surds, we can convert them into equiradical surds. So let's say we have cube root of a number and then we have square root of a number. So what is cube root of this number? This is y. Let's say x raised to 1 by 3, right? Now what is square root of this number? Y raised to 1 by 2, right? Can we write this 1 by 3 as x into, x raised to 1 by 2, and how do we split it? We have 1 by 3 and 1 by 2. How do we take the LCM? We could take 2 into 3. Let's convert it into 1 by 6. We have 2 by 6, right? And we have 3 by 6, right? We could convert x 1 by 3 and we'll multiply both of these numerators by the power of x raised to 1 by 2. Here we'll multiply it by x raised to 3 by 6. Now we'll convert it into the same radical. So we have x raised to 2 by 6 and we have y raised to 3 by 6, right? So we have x raised to 2 by 6 and y raised to 3 by 6. So what do we get? What do we get here? We have x raised to 2 by 6 and y raised to 3 by 6, and we could write it as x square into x raised to 1 by 6, and here we could write it as y cube into y raised to 1 by 6, right? So 1 by 6 and 1 by 6 we could compare, square and cube we could compare, right? Cube is greater than square, and 1 by 6 and 1 by 6, y raised to and x raised to 1 by 6, we could compare that number with each other, and thus we could actually convert a non-equiradical surd into an equiradical surd and compare them with each other. Now we have comparison of surds with the same radicand. If two surds of different orders have the same radicand, then the surd with the smallest order would be in the greatest value. Like if we have square root of 8 and cube root of 8, which would be greater? The radicand is same, but the square root would be greater than the cube root. The higher the order of the surds, the lower would be its value if the radicands are same. Let's see, what is the square root of 8? We have 2, 4, again 2, we have 2 again, 2 and 1. So this becomes 2 root 2. And what is the cube root of 8? We have 2, right? So 2 root 2 is obviously greater than 2. So the surds with the lowest order would have the highest value when the radicands are same. Now we'll talk about exponents. So an exponent is a little number written above and right of a number. So this is called the exponent of a number. We have already talked about it before. Now it tells us how many times to multiply that number by itself. We call the number we are multiplying by the base, and the little number to be the exponents. So we'll multiply the number exponent times the base, right? So this, it's 6 square. So we are multiplying 6, which is the base, exponent times, that is 2 times. We have 6 into 6, and that is equal to 36. Now this is all about the chapter exponents, powers and surd. I hope you all understood that. We'll just quickly go through what all we have talked about in this chapter. We started with what is exponential form. Then we talked about how to find the rational exponents. We talked about negative integral exponents. Then we moved on to laws of exponents. Then we talked about surds and radicals. We talked about surd in the simplest form. Then we moved on to types of radicals. And then we talked about comparison of two surds, and then we talked about different ways to compare two surds, and finally we ended with exponents. I hope this is very clear for you. Solve a lot of questions from this problems, and this is about the chapter surds and exponents, powers and surds.